Welcome to Maths with Bob. Today we are looking at finding equations of lines in coordinate geometry. And you can see here I've actually got the three forms of the straight line here. Y equals mx plus b, that's a famous one. M is the slope and b is the y-intercept. The general form, which is a rearrangement, if you like, ax plus by plus c equals 0. And I've included another point slope or slope point form of the line y minus y1 equals mx minus x1. That's when we have a point x1, y1 and we know the gradient. We can use that to get the equation of the line. Now, we use a lot of that in calculus. When we differentiate a curve, we can work out the gradient, if you like, of the curve of the point, and then to get the equation of the tangent, we just sub the coordinates of the point into that formula. So that's quite a handy formula to remember. Now, you'll notice I've actually haven't put the two-point form in here. The two-point form I shy away from a little bit, and we just use, if you like, the point-slope form usually. But I'm just going to go through some examples, but before we do an example, I just want to show you, if we actually have, let's see, we rearrange y equals mx plus b. So, mx, I'll put the y across, minus y, the b is still on the same side, equals 0. Okay, so that is, if you like, the y equals mx plus b form in what's called general form, okay? Now, we don't normally do that. Sometimes we can say, the question may say, please give the equation of the line in general form, and if you do it y equals mx plus b, you always have to do that sort of thing, rearrangement. Okay, or that sort of rearrangement, make it equal to 0. Okay. Now, let's have a look. A more useful idea is if you have a look at the general form and you rearrange that. So by is equal to what, minus ax minus c. Put the ax and the c on the other side. They become negative. And then I divide by b. Then y would equal minus a on bx minus c on b. Now, this is quite useful because you can see, the minus a on the b is actually the slope, m. Okay. And you can see also that the minus the c on the b is in fact the y-intercept. Okay, so if you had a line, you could quite easily, if it was in general form, just read off the gradient, minus the a value, which is the coefficient of x, divided by the b, which is the coefficient of the y, and that would give you the gradient of the line. Okay, and so if you divided the minus the c value by the b value, okay, the c is a constant and b being the coefficient of y, then you get what's called the y-intercept. Okay, that's quite a useful idea. Okay, let's do some quick example. Okay, here we have 2 points, A at 2, 3 and B at 4, 7. Now, the first thing with coordinate geometry I always say is whenever you come across some points, you would label them x1, y1, x2, y2. So basically, the first point you come across, you give it a number 1 subscript for the x and the y coordinates, and the next point 2, and next point 3, etc. So we want to find the equation of the line through these 2 points. Now, just before we start, we hopefully can see that the gradient is something like this. Now, that has a positive slope. Okay, so we're expecting to get a positive number out of this. Now, so if we got a negative number, we would know we'd done something wrong. Now, if it was down this way, we know that that would have a negative slope, okay, which is not the case, okay, in this situation. So we are expecting from our formulas to, in fact, get a positive value. So let's actually apply the formulas, okay. So there's something just to keep in mind, okay. We know that the m is y2 minus y1 on x2 minus x1. And we just put some numbers in. Now y2 we know is 7 minus 3, that's the y1 value. x2 you can see here is 4 minus the x1 value, which is 2, and you can see that's 4 over 2. So the m, or the slope value m, is actually equal to 2. Okay, now while we're on this, any other line which had a slope of 2 would be parallel to this line. Okay, there'd only be one line through AB with a slope of 2. So obviously we'd have to the equation of any other line with a slope of 2 would be different to the one we're going to get through A and B here. Okay, so the idea of parallel and perpendicular comes into coordinate geometry a lot. Just while we're here, perpendicular lines. what are they? Well, they're at right angles to each other, just like sometimes a tangent and a normal. But a perpendicular line and basically to has a relationship, I guess you could say, with the gradient of the original line, in that the m1 times the m2, that's the gradient of the first one times the gradient of the second one, is always equal to -1. Okay, so we can say that, for instance, this line has a slope of 2. The one which would be perpendicular to it would have, sometimes say the negative reciprocal, which is -1/2. But if you get those two gradients, like -1/2 and 2, and multiply them together, you should get -1. And so what a lot of people say is, well, multiply the two gradients together. If it's -1, the two lines are in fact perpendicular. Now let's actually get the equation of the line. Now, just first up, we know the equation of the line can be written lots of different ways. Well, we always start with y equals mx plus b. I think this is the easiest way. Y equals mx plus b. Because you already know the slope 2, so you know the line has basically the equation y equals 2x plus something, b. Now, what is the b? Well, the b is the y-intercept. Now, if you have a quick look here, I draw a line through these 2 points. Okay, the y-intercept, well, we don't know where it is. It's down, obviously, under the x-axis somewhere, but that y-intercept value is not known at the moment, and we have to try and find out where it is. So what we would do is, well, we need to substitute, because both points are on the line, we can substitute any point into that to actually find the value of b. So let's actually sub in, say, a. So we sub in a, and a is at 2, 3. So what we do now is we make the x value 2, so 2 times 2 is 4, and the y value is 3. Therefore, let's have a quick look. 3 is equal to 2 times 2, which is 4, plus b. Therefore, okay, b would be equal to -1. Therefore, the equation of the line, okay, b equals -1. Now, we've got the equation of the line now, okay. The equation of the line would be what? Y equals 2x, we know the slope's 2, and then we've just found the y-intercept, -1. Okay, wow, this is the equation of the line, right? So the equation of the line, going through here, this equation is y equals 2x minus 1. This value down here, hallelujah, we just found -1, the y-intercept. And we know the slope is in fact 2, and now we've got the equation. Okay, well, thank you for watching. Bye for now.